We have a motorboat that travels upstream and then downstream. We are asked to determine the rate of the current, so that's our first variable, let's call that C, and also what the rate of the boat is in still water. So that's our other variable, let's call that R. Variables are often revealed in the questions that are being asked. We want to create a table with rate times time equals distance for the trip upstream and downstream. Filling out this table is going to make writing the two equations necessary to answer these questions much easier. The distance the boat travels upstream is 192 kilometers. When it returns downstream, it's making the same trip. So when it goes downstream, it also travels a distance of 192 kilometers. Traveling upstream, the boat takes 4 hours. So let's fill in upstream time 4. When the boat returns going downstream, it takes the boat 3 hours. So let's fill in the downstream time with the number 3. For a boat to be going upstream, it means it's going against the current. In other words, the current is slowing the boat down. The speed of the boat going upstream is going to be the rate the boat would be going without the current, and then subtract the current because the current is slowing the boat down. This makes the upstream rate R minus C. Finding the downstream rate is very similar. When the boat is going downstream, it is going with the current, so the current is making the boat go faster. So the downstream rate is the boat's rate plus the current since it's speeding it up. Now that our table is filled out, we're ready to use rate times time equals distance to write our two equations. Looking across from upstream, the first box multiplied by the second box equals the third box. So 4 multiplied by R minus C is equal to 192. Looking across from downstream, the first box multiplied by the second box is equal to the third box. So multiplying the first two boxes together, 3 times R plus C, that's going to equal 192. To solve this system of equations, I'm ultimately going to use the elimination method. But before we use the elimination method, let's go ahead and distribute the coefficients out front. Distributing the 4 through, I have 4R minus 4C, bring down the equals 192. Distributing 3, I have 3R plus 3C equals, bring down the 192. I'm going to eliminate the variable C, and to do this, I'm going to need to make the negative 4C in the left equation a negative 12C, and the positive 3C in the right equation positive 12C. To make the negative 4C on the left a negative 12C, I'll need to multiply by 3. What I do to one side of the equal sign, I do to the other. So multiplying both sides by 3, 4R multiplied by 3 is 12R. Negative 4C multiplied by 3 is negative 12C. And then 192 multiplied by 3 is 576. Moving on to the second equation, let's turn that 3C into a negative 12C by multiplying both sides of the equal sign by 4. 3R multiplied by 4 is 12R. 3C multiplied by 4 is 12C. And 192 multiplied by 4 is 768. The C's are now opposites, so we're ready to draw a line and combine. 12R plus 12R gives me 24R. The negative 12C and 12C eliminate, bring down the equal sign, and 576 plus 768 is 1,344. To finish getting R by itself, let's divide both sides by 24. So we find that R is equal to 56. The 56 is the rate of the boat in still water. So now let's substitute 56 back into either one of the equations we created. It doesn't matter which equation we select, we'll get the same answer. So starting with the equation on the left, I'm replacing the R with 56. 4 times the 56 gives me 224. Subtract that over. Then get rid of multiply by negative 4, and I get 8. Although not necessary, I went ahead and substituted 56 into the other equation just so that you could see we would also come up with C equals 8, the rate of the current.